Hi, welcome to the Euclidean Geometry 101 course. In this part, we will talk about plane figures and when they coincide. We will introduce the concept of congruency. Let's look at these plane figures. A plane figure is a figure that is situated completely in a plane. By the way, when does a plane figure completely fall in a certain plane? Well, when the plane figure has 3 points in common with the plane and those 3 points are not collinear, then we are sure that the figure lies in the plane. Suppose we want to move a plane figure around. Then we could ask ourselves what kind of operations we can execute on a plane figure without changing the plane figure itself. Let's look at this practically. I have cut out a few paper figures. Firstly, we can move a figure around in all directions in the plane, and we call these movements in mathematical terminology translations. Secondly, we can turn a figure to the left or to the right. These rotations, as they are called in maths, always preserve one point, the center point around which we rotate the figure. And thirdly, we can also flip the figure over. This is called a reflection. Remark that in order to reflect a figure, we have to pick the piece of paper up. Let's view this again, somewhat more formally this time. So we can move the figure in the plane. When translating, all points of the figure move in a specific direction over the same distance. When rotating, all points of the figure rotate around a fixed point over a fixed angle. The transformation is often a combination of a translation and a rotation. The third type of movement is a reflection. To explain this, you should realize that a plane figure has two sides, like the recto and verso of a piece of paper. The name of this movement is like the reflection in a mirror, as you get the same effect by looking at the figure in a mirror. The recto becomes the verso and vice versa. This is different from a translation or rotation where the recto always stays recto and the verso always stays verso. So it is important to realize that you cannot change a figure in its reflected version by using a combination of a rotation and a translation alone. To visually explain the reflection operation, we actually have to move outside of the plane. Only the start and end step of the reflection process are in the same plane. Between those two steps, we leave the plane. Let's consider a few plane figures. It can be interesting to see if some of the figures could coincide with other figures, because that allows us to conclude that those figures are equal. There are three possibilities when trying to make a figure coincide with another. The first possibility is that a figure cannot coincide with another. The second possibility is that we can make the figures coincide by using a translation combined with a rotation. And the last possibility is that we also need to include a reflection together with a translation and or rotation to make the figures coincide. If two figures can coincide completely with each other, then we call those figures congruent. Two figures that can coincide by only using a translation and a rotation are called directly congruent. Two figures that can only coincide by also using a reflection are called inversely congruent. There is a mathematical symbol that is used when denoting congruency. Exercises in plane geometry often come down to testing congruency of figures or parts of figures. We will see in future lessons that for some figures, especially triangles, there are some simple rules to test for congruency. Here, however, we will detail a general visual procedure in 4 steps to determine congruency between two figures, especially for those figures that are polygons. The first step consists in naming all vertices of each figure in the same order, clockwise or anti-clockwise, whichever you prefer. In the example, we have the figures ABC and A', B', C'. The second step consists in taking a vertex of the first figure and translate it until it coincides with the matching vertex of the second figure. The third step consists of rotating the translated figure around the matching vertex until a side of the first figure coincides with a side of the second figure. We now see the two figures coincide completely with each other. So there is a direct congruency between ABC and A', B', C'. Let's now follow the same process, but with A', B', C'. The first 3 steps are the same, but we see that we cannot yet let the two figures coincide. We have to perform a 4th step, called a reflection, around the coinciding side. And after this, the figures coincide completely. So there is an inverse congruency between ABC and A', B', C'. This general procedure to test for congruency is of course impractical to use in proofs, which is why we will need some simpler tests. Now that we have defined congruency for figures in general, we will look at a special class of figures called polygons in the next lesson. If you like this series, consider subscribing to my channel.